Welcome to Lithi-Zim. Today's video is hosted by Sage Wagner, a highly skilled geologist and geophysicist who will guide you through the exciting world of geoscience. Join us as we explore Earth.
A group of experienced gold miners set out on a journey to find a legendary gold deposit, said to be worth billions of dollars. The team, led by a charismatic and determined leader, must navigate harsh terrain, dangerous wildlife, and rival mining companies, all while dealing with their own personal demons. As they get closer to their goal, the team discovers that the deposit is located on sacred land belonging to a local tribe. The miners must find a way to work with the tribe, whose help they need to access the gold, while also respecting their culture and traditions. As the stakes get higher and tensions rise, the team must make difficult choices to achieve their goal, but will the cost of success be too high? Golden Rush is a thrilling action-adventure film that will keep you on the edge of your seat until the very end. With stunning visuals, an all-star cast, and a heart-pumping soundtrack, this movie is sure to be a box office hit. The Witwatersrand Basin in South Africa is a prime example of a placer deposit, where gold is found in conglomerate rock formations. These deposits are formed by the erosion and weathering of primary gold deposits, leading to the concentration of gold in alluvial gravels and sands. The Witwatersrand Basin is the most important gold-producing area in the world, with an estimated 40% of all gold ever mined coming from this region. Another important type of gold deposit is the Carlin-type sediment-hosted disseminated gold deposits found in Nevada. These deposits are characterized by fine-grained gold dispersed throughout sedimentary rocks, such as shale and siltstone. The Carlin-type deposit is unique in that it is a low-sulfidation deposit, which is a contrast to the typical high-sulfidation epithermal deposits. The Carlin mine in Nevada is one of the most productive gold mines in the world, with over 50 million ounces of gold produced to date. Additionally, Archean banded iron formation gold deposits, such as Homestake mine in South Dakota, is another important type of gold deposit where gold is found in association with iron oxide minerals, such as hematite and magnetite. Gold deposits can be found in a variety of geological settings and can be related to other ore types. One common type of gold deposit is the epithermal deposit, which forms in volcanic and near-surface environments. These deposits are characterized by low sulfidation mineralization, and are often associated with other precious and base metals, such as silver and copper. Another type of gold deposit is the mesothermal deposit, also known as orogenic deposits, which forms at greater depths and is related to tectonic activity. These deposits are characterized by high sulfidation mineralization, and are often associated with other base metals such as copper, lead, and zinc. Additionally, gold deposits can also be found in association with other types of deposits like porphyry copper deposits and skarn deposits. Understanding the relationship between gold deposits and other ore types can aid in exploration and discovery of new gold deposits. Nevada is one of the most productive gold-producing regions in the world, with a total production of 8.6 million ounces of gold in 2000, nearly as much as Australia's 9.5 million ounces. The state is known for its Carlin-type gold deposits, which are characterized by fine-grained gold dispersed throughout sedimentary rocks. These deposits are unique in that they are low-sulfidation deposits, in contrast to the typical high-sulfidation epithermal deposits. Nevada has more than 40 known Carlin-type deposits, with the Northern Carlin Trend alone accounting for 66 million of the 120 million ounces, production plus reserves, estimated for all such deposits. The Carlin mine in Nevada is one of the most productive gold mines in the world, having produced over 50 million ounces of gold to date. Nevada is one of the most productive gold-producing regions in the world, with the majority of gold mined being tiny, microscopic in size. However, a small percentage of the gold is large, and an example of this can be seen in a pan full of gold taken from the Round Mountain Mine in Nye County. The Round Mountain Mine is known for the production of coarse gold, and it is estimated that only about 3% of their total production is in the form of coarse gold, but even 3% of all their gold is a large quantity. This is due to the presence of large veins and nuggets in the mine. This highlights the importance of understanding the different types of gold deposits and their characteristics, as different deposits can have varying percentages of coarse and fine gold. Carlin-type deposits are a unique type of gold deposit, characterized by relatively high O/Ag ratios, enrichment in As, Sb, Hg, and Tl, and by the dominance of invisible gold, as ions or submicron-sized particles in iron sulfide. These deposits are generally, but not always, hosted by Paleozoic carbonate rocks. The formation of Carlin-type deposits is thought to have occurred from relatively low temperature, 150 to 250 degrees Celsius, low pH, and low to moderately saline fluids of mixed meteoric and magmatic or metamorphic origin. The age of most Carlin-type mineralization in north-central Nevada is late Eocene, which suggests a genetic relationship with coeval regional magmatism. This has led to the hypothesis that the formation of these deposits is linked to the tectonic activity and magmatism that occurred during the late Eocene. The discovery of Carlin-type deposits in other parts of the world, such as China and Brazil, supports this hypothesis and highlights the importance of understanding the geology of a region in order to identify and explore for these types of deposits. Host strata in north-central Nevada play an important role in the formation and distribution of gold deposits. The total gold endowment of stratabound gold deposits in the area is substantial, with several places in Nevada, such as Carlin, Round Mountain, and Cortez, having significant amounts of gold in their host strata. These strata, which are typically composed of Paleozoic carbonate rocks, act as a source of both gold and other metals, and provide a favorable environment for the formation of gold deposits. The presence of these host strata in north-central Nevada has led to the discovery and development of several large gold mines in the area, making it one of the most productive gold-producing regions in the world. The understanding of the role of host strata in gold deposits is crucial for identifying and exploring new gold deposits in the region. Mineralization trends in Nevada are an important aspect to consider when exploring for gold deposits. One of the most well-known mineralization trends in the state is the Carlin trend, which is a northwest-southeast trending belt of gold deposits that stretches from Elko County to Eureka County. The Carlin trend is known for its Carlin-type deposits, which are characterized by fine-grained gold dispersed throughout sedimentary rocks and are unique in that they are low sulfidation deposits. The Hollister property, owned by Great Basin Gold, is located within this trend and is known to have significant gold mineralization. The Carlin trend is considered to be one of the most important gold-producing regions in the world, with over 50 million ounces of gold produced to date. This is due to the presence of large, high-grade gold deposits, such as the Carlin mine and the Goldstrike mine, which are both located within the trend. The trend is also known to have potential for additional discoveries, as exploration activities continue to identify new gold targets. The Carlin trend is considered to be so special for finding gold because of the presence of large, high-grade deposits in the Po. Nevada is home to several important sediment-hosted gold deposit trends, including the Battle Mountain Eureka Trend, the Getchell Trend, the Alligator Ridge Ground, the Carlin Trend, and the Independence Group. These trends are characterized by gold deposits hosted within sedimentary rocks and have been significant sources of gold production in the state. The Battle Mountain Eureka Trend is located in north-central Nevada and stretches from Lander County to Elko County, and is known for its Carlin-type gold deposits. The Getchell Trend, also located in north-central Nevada, is known for its high-grade, low-sulfidation gold deposits. The Alligator Ridge Ground is located in northeastern Nevada and is known for its Carlin-type gold deposits. The Carlin Trend is a northwest-southeast trending belt of gold deposits that stretches from Elko County to Eureka County and is known for its Carlin-type deposits. The Independence Group is a group of gold deposits located in the Independence Mountains in west-central Nevada. The Manhattan Deposit, also known as the East Manhattan Project, is a gold deposit located in Nevada, USA. The deposit is located in the Manhattan Mining District, in Nye County, and it is considered to be one of the largest undeveloped gold deposits in Nevada. The deposit is a Carlin-type deposit, which is characterized by fine-grained gold dispersed throughout sedimentary rocks, and is unique in that it is a low-sulfidation deposit. The deposit is estimated to contain over 4 million ounces of gold, making it a significant gold resource. The deposit is currently under exploration and development by different mining companies, with the goal of bringing the deposit into production. The Manhattan Deposit is considered to be an important discovery in Nevada due to its large gold resource and its location in an established mining district. The Goldstrike, Postbets, mine, located in the Carlin Trend of Nevada, is the largest Carlin-type deposit in the world, containing over 35 million ounces of gold. The Carlin Trend is a northwest-southeast trending belt of gold deposits that stretches from Elko County to Eureka County and is known for its Carlin-type deposits. The Gold Strike mine is considered to be one of the most important gold mines in the world and has been in production since 1987. The mine is operated by Barrick Gold Corporation, one of the largest gold mining companies in the world. The deposit is a sediment-hosted disseminated gold deposit, composed of fine-grained gold dispersed throughout sedimentary rocks, and is unique in that it is a low sulfidation deposit. The Gold Strike mine has produced more than 35 million ounces of gold, making it one of the most productive gold mines in the world. The mine is also considered to be a prime example of the Carlin-type deposit, which is a unique type of gold deposit that is known for its large gold resources, and has been the subject of much research and exploration in the industry. Carlin-type gold mineralization is a unique type of gold deposit characterized by several signature characteristics. The first characteristic is the presence of favorable sedimentary rocks, such as silty limestone and limy silt stones, which act as a host for the gold mineralization. The second characteristic is the presence of a favorable faulted structure, which provides a pathway for the gold-bearing hydrothermal solutions to migrate and deposit the gold. Another characteristic is the presence of nearby gold deposits, which suggest a regional control on the formation of these deposits. The most important characteristic of Carlin-type deposits is the presence of gold in large amounts, which makes it a highly valuable resource. These elements, favorable sedimentary rocks, favorable faulted structure, gold-bearing hydrothermal solutions, nearby gold deposits and large amounts of gold, are crucial for the formation of Carlin-type gold deposits. The Homestake mine, located in the North Black Hills of South Dakota, is an important gold deposit that is hosted by Precambrian iron formation. The Homestake deposit is unique in that it is an iron formation-hosted O deposit, where gold is found in association with iron oxide minerals such as hematite and magnetite. The iron formation-hosted gold deposits are considered to be one of the oldest and most important gold deposit types, dating back to the Archean era. The Homestake deposit is considered to be one of the largest and most productive gold mines in the United States, with an estimated production of over 40 million ounces of gold. The deposit was in production for more than 120 years, and it's considered a good example of the iron formation-hosted gold deposits, which are known for their large gold resources and long mining history. The deposit was closed in 2002, but it remains an important site for scientific research and geologic study. The Homestake O deposit, located in the North Black Hills of South Dakota, is a world-class deposit and a type example for Precambrian iron formation-hosted O deposits. The deposit was mined for over 126 years underground, and produced an estimated 40 million ounces of gold. The deposit is hosted in metamorphosed Precambrian rocks that are around 2 billion years old. The associated rocks include mthol-iitic basalt and metasediments such as dirty dolomite, carbonate-rich claystone and siltstone, iron formation, exolite, and tuffs, which are now phyllites. The deposit is found in the Homestake and Portman formations, which are believed to be the result of basin fill followed by seafloor volcanic exhalative activity. The deposit is formed under middle greenschist to middle amphibolite metamorphic grade. This deposit is a valuable resource for geologists and mining industry, as it provides insight into the formation of world-class gold deposits and the geology of the area. Iron formation. Grunrite siderite biotite quartz chlorite schist is a type of metamorphic rock composed mainly of the minerals grunrite, siderite, biotite, and quartz, with smaller amounts of chlorite. The rock is typically composed of grunrite biotite quartz schist, almandine and chlorite. It also can be present in the form of biotite quartz siderite phyllite or schist, and cherty chlorite quartz siderite phyllite. This rock is interpreted as a carbonate facies iron formation, formed in a low-energy restricted basin. The presence of iron minerals such as grunrite, siderite, and hematite in this rock suggests that it formed in an iron-rich environment. The rock also contains other minerals such as biotite and quartz, which are typically found in metamorphic rocks. The grunrite siderite biotite quartz chlorite schist is an important rock type for understanding the geology of the area it is found in, and for understanding the formation of iron-rich deposits. Mineralization is the process by which valuable minerals, such as gold, are concentrated in a specific area. The ore mineralogy of the mineralization process often includes the presence of pyrrhotite, arsenopyrite, plus or minus pyrite, and native gold in the gangue, which are minerals that are associated with gold deposits. Silver is often a byproduct of this mineralization process. The mineralization is typically hosted by quartz veining and ductile shear zones, which are structures that can form as a result of tectonic activity. The mineralization is typically found in individual ore bodies that are relatively undeformed, pipe-like to tabular bodies that can vary from sparse to densely clustered. These ore bodies are formed by the precipitation of minerals from hydrothermal fluids that have been injected into the host rock. The mineralization process and the ore mineralogy are important aspects to consider when exploring for gold deposits and understanding the geology of an area. Diamond drill core samples from the Homestake gold mine at Lead, South Dakota are an important tool for understanding the geology and mineralization of the mine. Diamond drilling is a method of drilling that uses a diamond-tipped drill bit to cut through rock, allowing geologists to collect samples of the subsurface materials. The samples collected from the Homestake gold mine are critical for understanding the geology of the deposit, as well as the distribution of minerals such as gold and silver. These samples can be used to determine the structural geology, alteration patterns, and mineralogy of the deposit. Additionally, these samples can also be used to determine the grades and thickness of the mineralization, as well as the continuity of the deposit. The diamond drill core samples from Homestake gold mine are a valuable resource for geologists and mining companies as they aid in exploration, resource estimation, and mine planning. The Witwatersrand O deposit in South Africa is a type of deposit known as O in conglomerates. This type of deposit has been mined since the 1880s, and is considered to be one of the most important gold deposits in the world. The deposit is hosted in the Archean or Paleoproterozoic rocks of the Central Rand Group, which is the upper part of the 3.07 to 2.7 Ga Witwatersrand supergroup. The deposit is generally metamorphosed to greenschist facies. The Witwatersrand deposit is known for its O-pyrite-carbon association, which is a common mineral association in these type of deposits, and is found in conglomerates or sandstones. The Witwatersrand deposit is considered to be a unique deposit, due to the large size of the gold resources, the long mining history and the significance of the deposit for understanding the geology of the area and the formation of gold deposits. Ore textures refer to the physical characteristics of the minerals in an ore deposit. In the case of gold deposits, the gold is often found to be late paragenetically and is associated with carbon and hydrothermal sulfides. This means that the gold mineralization formed later than the other minerals in the deposit and is commonly found in association with carbon and sulfide minerals. Some studies have suggested that the gold may have been remobilized, possibly due to fluid activity in the deposit. The metal associations of the deposit are also important, with O, U, as, company, Hg, and Ni commonly found in these type of deposits. Alteration is also an important aspect of ore textures, where minerals such as pyrophyllite, chloritoid, muscovite, and chlorite can be found. These minerals are typically formed due to alteration of the host rock by fluids and are used as indicators of the mineralization and alteration history of the deposit. The study of ore textures is important for understanding the mineralogy, geology, and the genesis of ore deposit. The Witwatersrand Basin, also known as the Rand Groups, in South Africa is home to one of the most important gold deposits in the world, known as the Witwatersrand goldfields. The basin is a sedimentary basin that formed around 2.8 billion years ago and is host to a number of gold-bearing conglomerates, known as the Witwatersrand supergroup. The gold deposits in the Witwatersrand Basin are considered to be some of the most important in the world due to their large size, long mining history, and significance for understanding the geology of the area. The Witwatersrand Basin is also part of the larger Bushveld igneous complex, which is a large layered mafic intrusion that intruded the Archean rocks of the region, around 2.06 billion years ago. The Bushveld igneous complex is a source of many important mineral resources including platinum, chromium, and vanadium, as well as gold. The Bushveld igneous complex is considered to be a unique geological feature and a valuable resource for geologists and mining industry. The complex is also important for understanding the geology and mineralization of the area and the formation of mineral deposits. The Witwatersrand gold deposit, located in South Africa, is considered to be one of the world's largest and most valuable gold deposits. However, its origin remains a major enigma. Several models have been proposed to explain the origin of the deposit, but none of them fully explains all of the observed characteristics. The paleoplacer model suggests that the gold was originally deposited as a placer in an ancient river system, but this model has been challenged by the lack of evidence for an ancient drainage system in the area. The hydrothermal model suggests that the gold was deposited by hot fluids circulating through the rocks, but this model has also been challenged by the lack of evidence for a hydrothermal system in the area. The modified paleoplacer model suggests that the gold was originally deposited as a placer in an ancient river system, but was later remobilized by fluids and redeposited in a new location. The hydrothermal model for gold and modified paleoplacer for other components suggests that the gold was deposited by hot fluids circulating through the rocks and other minerals were deposited by an ancient river system. The models for the origin of the deposit appear. At a microscopic scale, the gold in the Witwatersrand deposit is typically found to have a hydrothermal texture, suggesting that it formed as a result of hot fluids circulating through the rocks. However, this observation raises questions about the origin of other minerals found in the deposit, such as pyrite, uraninite, and carbon, bitumen. These minerals are also typically associated with gold deposits, and their presence in the Witwatersrand deposit suggests that they also formed as a result of fluid activity. But, the question of whether these minerals formed at the same time as the gold or were remobilized at a later stage remains unresolved. Some studies have suggested that pyrite, uraninite, and carbon, bitumen, were remobilized by fluids, but it's not clear if this is the case for all the deposit. The origin of these minerals and their relationship with gold mineralization at the microscopic scale is still an enigma, and further research is needed to understand the origin of these minerals in the Witwatersrand deposit. At a microscopic scale, the Witwatersrand deposit also exhibits rounded pyrite. This shape suggests that the pyrite could have formed through a detrital or replacement process. The detrital process would suggest that the pyrite was transported by water and deposited as sediment, while the replacement process would suggest that the pyrite replaced an earlier mineral. The rounded shape of the pyrite could be an indication of the pyrite being transported by water, but the absence of other sedimentary structures makes it difficult to confirm this hypothesis. The replacement process suggests that the pyrite formed in place by replacing an earlier mineral. The shape and mineralogical association of the pyrite are not clear enough to determine if it formed by detrital or replacement process. Further research is needed to understand the origin of the rounded pyrite in the Witwatersrand deposit, and how it relates to the mineralization process. At a basin scale, the Witwatersrand deposit is located in a foreland basin setting, which is a type of sedimentary basin that forms in front of a mountain range. Foreland basins are typically formed by the flexure of the crust as a result of the weight of the overlying mountain range. The Witwatersrand Basin is a sedimentary basin that formed in front of the Kaapvaal Kraton, a large and ancient landmass that is now part of South Africa. The basin is known for its thick pile of sediments that were deposited in a shallow marine environment and were later metamorphosed. The Witwatersrand deposit is hosted in the upper part of the Witwatersrand supergroup, which is a sequence of metasediments, volcanic rocks, and intrusions that were deposited in the basin. The basin scale setting of the Witwatersrand deposit is important for understanding the geodynamic setting of the deposit and the formation of the basin. The review of the deposit at the basin scale can help to understand the depositional environment, the structural setting, and the tectonic evolution of the area, which can help to understand the mineralization process and the origin of the deposit. The most probable genetic model for the Witwatersrand gold deposit is one that involves a combination of orogenic and placer processes. The deposit is thought to have formed during the late Archean period, which was a peak time for orogenic gold globally. This model suggests that the gold was sourced from a world-class gold deposit, formed by the chemical erosion of rocks in a highly acidic environment, and then transported by braided streams to the Witwatersrand Basin, where it was reworked and concentrated through sedimentary processes. This process is also supported by the fact that the Witwatersrand deposit is one of the most modern giant placer deposit, where gold is not sourced from other world-class gold deposits. It is believed that the lack of vegetation and rare organisms in the area, increased wind sorting on exposed bars and faster spreading rates, with greater uplift at arc stage, and greater sedimentary reworking in constantly reactivated braided rivers may have all contributed to the formation of this deposit. Preservation. The Witwatersrand paleoplacers are unique in that they have been exceptionally well preserved over time. This is due to the time of plate plume interactions that produced unique Archean lithosphere in the area. The Kaapvaal Kraton, which is part of the Witwatersrand Basin, represents the oldest continental lithosphere, and the deposit preserves one of the oldest clastic sedimentary basins and a unique Precambrian stratigraphic section. Erosion protection. The Witwatersrand deposit is also unique in that it has been protected from early erosion by the extension and Venterstorp lavas. This is in contrast to other large placers, such as the Paleozoic Ballarat deposits, which were preserved under basalt. This makes the Witwatersrand deposit one of the most well-preserved large placer deposits in the world and sets it apart from other placers found around the Pacific margin, which are typically much more recent.
Thank you for watching. We at Lithi-Zim appreciate your support. It is with great pleasure that we get to bring you these videos about geology, geophysics, GIS, and computer science. Until next time.